Alrighty, guys. Good afternoon. Today we are going to finish up part A. Okay, good afternoon. We're going to go ahead and finish up part A of chapter 6, which is the 6-4, and we're going to learn the applications of linear systems. The beauty of learning 3 different formats is that we have 3 different ways to solve problems. And those 3 ways to solve these linear equations, or these linear systems, is one by graphing. I would only use graphing, though, my friends, when it's very, very easy to graph. When they give you something so simplistic that it begs you to graph it. For example, if I gave you, find the solution of y equals x and y equals x plus 1, I wouldn't even think about it. Okay? I wouldn't even think about it, guys. Well, in this case, there'd be no solution, right? But let's just say it was 2x. I would just graph it out, find the intersection point. That's what I mean by nice and easy linear equation. Don't graph it if it's y equals 2/3 x plus 4.17. That's going to be very difficult to graph. Substitution. You want to use substitution when one variable is already solved for or is very easy to solve for. What am I talking about? You want to use substitution when you have already, when they say, for example, x equals 2y plus 8 and 2y minus 7x equals 15. Well, you already know what x is, so you simply plug that into the x. That's when you use substitution. When they've already solved one variable for you, or when it's very easy to solve that variable. For example, if I give you 5x plus y equals 9, and then 7x plus 3y equals 12. I'm just making these numbers up. In this case, I would also consider substitution. Me personally, it's in standard form, I'm going to go elimination. But that's just me. But you could consider substitution here because all you have to do is subtract the 5x, and then you have that y equals negative 5x plus 9. You know what y equals, and you plug it into the y. So you use substitution once again when a variable is solved for you already. That's a guaranteed automatic substitution. And then if it's very easy to solve for one variable, you can go ahead and use substitution as well. Elimination, straight up, it's when it's in standard form. You have 2x plus 3y equals 9 and 5x minus 6y equals 12. A standard form, boom, go for it. Eliminate the x or the y, and we already know how to do that. We know the mechanics. So today we're simply going to do some word problems, and we're going to use different strategies or methods, thank you, for solving. I will tell you this right now. 99.9% of the word problems, I will never, ever use the graphing method on 99.9%. Because you're going to have really large numbers usually for word problems. You're going to have decimals or fractions or percentages. Very difficult to graph those. Not impossible, but very difficult. So 99.9% of the time you will not use graphing method to solve equations, word problems. Sir? Yes, the question was, can't you use substitution and elimination whenever? Yes, absolutely. But again, it's very easy. It's a lot easier to use substitution when you already have one variable solved for. Okay? Thank you, sir. So, let's get to it, my friends. Don't worry, this is the new stuff that I added, okay? So, if you have the old printout, you're going to have to add some stuff. Let me read everything first. Let me explain this new vocabulary to you, and then I'll show you how to solve this problem because it's really simple. A company makes and sells hats. Before I even continue, you do realize, guys, I'm not trying to be sarcastic, but you do realize when you make something, whether it's hats or widgets or whatever, it is going to cost you money to make it, right? Okay, I'm not trying to be sarcastic, but when you make something, it does cost you money. For example, the PlayStation 3. They sell it for 250. It didn't cost them 250 to make it, but it cost them something to make it. Okay, there is a cost always. Sir?
But when you make like a software, that cost?
If you make a software, that's a great question. Does it cost anything? Yes, your intellectual time. I'm not trying to be sarcastic. That it's a special person that can write software or write code for a program, and what you're paying for there is their intellectual property. Thank you. That's a great question, son. So that's the cost there, sir. So a company makes and sells hats. The material for each hat costs $550. The hats sell for $1250 each. The designer spends $1,400 on advertising. How many hats must the company sell to break even? Huh? Let's figure this all out. First of all, guys, let's talk about what revenue is. Revenue is gross earnings. That means the total of what you make before you pay your employees, before you pay taxes, before you pay the manufacturing costs, before you pay the rent for the location, before you pay electricity. This is simply what you make, what you have earned before you pay anything else off. Revenue is what you make. You feel me so far? So for example, here they're selling each hat for $12.50. So if I sell 100 hats, they made $1,250. Okay? That's not what they keep. That's not their profit, but that is what they made. Revenue is just what you make before you pay anything off. Does that make sense so far? Thank you. Expenses. Expenses are your costs. What you spend. That has nothing to do with what you make. What you spend is what you spend. What you make is what you make. They do not coexist. They do not coexist. Revenue is revenue, expenses is expenses. They're two totally separate entities. Does that make sense so far as well? Now, profit. Profit is when you take your revenue and you subtract your expenses. That's when you make money for real. For example, if my revenues are $10,000, $10,000, and my expenses were $7,000, what's my total profit? $3,000. That means that after I've paid everyone and everything and all my bills and everything, I made $3,000. I can put that in my pocket. I can put that in the bank. That is what I earned and made after I paid everyone off. Sir, if you have negative profit, that means you lost money. Yes, sir. Then it won't be profit. It would be called a loss. So to be technical, this is a profit/loss equation. Thank you, son. Good point. So that's a profit/loss equation. Well, no, that doesn't look good. Let's go back to what I did. Okay. Profit/loss. Okay? Does that make sense so far? Now, they're talking about here break even. What do you guys think break even is before yes, sir? It's not, that doesn't, I don't understand what that means. Yeah, no, you're not. No, close. Break even. You're all saying the same thing without saying it correctly. That's it. You've made as much as you spent. Break even is when revenue, not minus, dummy, when revenue equals expenses. Sorry. Equals expenses. Sometimes Mr. Morrow doesn't think. Thank you for that. We all make mistakes. So break even is when revenue equals expenses. Does everyone understand the vocabulary we just went over right now? You promise? Promise? Okay, because I'm going to go ahead and shrink this. Actually. Come again, son? Oh, yeah. Not just for this class, but if you guys, a lot of you I know want to become businessmen, this is the way to do it. Well, what am I doing here? You know what? Let me just... Why is that? Oh, because it's that. All right, let me just do this. I'll just work up here. Okay. Let's talk about this now, guys. So a company makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50. The designer spends $1,400 on advertising. How many hats must the company sell to break even? In order to break even, we just said that means that revenues have to equal expenses, right? So guess what? Y is going to equal your revenue or your expense. It's going to equal both. You know why? Because your revenue depends on how many hats you sell, doesn't it? Guys? And don't your expenses also depend on how many hats you sell? The more you sell, the more it costs you, correct? Okay, so that's your Y. Your X is the number of hats you sold and or made. So X will be your hats. So everyone understand my variables so far? Now let's get two equations up here. We're going to have a revenue equation and an expense equation. What do y'all think of revenue, what you make? What would that equation be? Excuse me. Yes, sir? Y equals 12.5x. Very good. That's my revenue. You got to put the Y. Y, remember, equals revenue in the revenue equation or expenses in the expense equation. Does that make sense of what you make? Every time you sell one, you make $12.50. Does that mean that that's your profit? No. That just means what you're collecting. The total of what you've collected. You haven't paid any bills with that. You guys feel me, right? What would my expense equation be? Yes, sir. No, almost. Plus 1,400. It equals $5.50 for every book I made, plus I had 1,400. He had originally said 550x minus 1,400. It's not minus because, remember, this is your expense equation. You're going to add up all of the expenses to get a total expense, right? Does that make sense, my brother? Thank you, son. Yes, sir. Okay, so now, we're done. Doesn't Y equal Y? Don't I want to find the break even? Doesn't break even mean when revenue equals expenses? So doesn't 12.5x have to equal 5.5x plus 14? Do you guys see what I just did there? Do you guys see what I just did there? Okay. So now it's Mickey Mouse time, y'all. Now we can just flow through this. Subtract 5.5x to both sides. You get 7x equals 1,400 divided by 7. So x equals 200 hats. You need to make 200 hats to break even. Now, how much money did you earn and how much money did you spend at that break even point? How would you figure that out? Plug it in. Thank you. Guys, wouldn't your revenue, what you made, be Y equals 1250 times 200? Does that make sense, guys? Yes or no? Okay, so that's going to be, I think, 2,500. Let me see. See if I'm right here. Yep. So I made 2,500. What about my expenses? What should my expenses be if this is the break-even value? 2,500. Let's just prove it, though. Y equals 5.5 times 200 plus 1,400. And I promise you that comes out to 2,500. So look and analyze what we just found. We were asked for how many hats must the company sell to break even. We got that right here in green and blue. We got to sell 200 hats to break even. At 200 hats, I didn't make $1, but I did not lose $1. If that was your business model, would this be a good business to get into? Absolutely it would. Okay, some of you say yes, some of you say no. Guys, how many people just in America, in the United States of America? Do you know how many people are here? There's like over 300 million. No, in America. America is not the world. In the world, there's about 300, a lot more than 300 million, almost 400 million. But let's just say 350 million. Guys, 350 million, all you need is 200 sales. I think that's a good deal. Now, if the break-even point was 1,000,000 hats, would that be good? No, that's too much. But 200 hats, that's very doable. Now, 12.50 for a hat is actually real cheap. But yes, but that's different. That's when you get into economics. So does everyone understand what I did here? So 200 to break even, and then if they wanted to know what is the cost of the break-even point, what is the revenue of the break-even point? Well, you plug it in, just like we have been learning to do. Does that make sense? Promise? All right. Let's do it. Let's do another one then, gentlemen. Oh, wait a second. Whoa. Oh, I almost gave you free answers there. Hold on. I know you guys would not have cheated. I know. But I want you to see that you can do this on your own. You don't need any help from me. Okay, let's do this. A teacher wrote a new book, a new travel book. The initial costs are $864. Binding and packaging each book costs 80 cents. The price of the book is $2. How many copies must be sold to break even? First, what's our first thing we always do? Label. So Y is, in these particular cases, when we're talking about break even, Y is going to be both revenue and expense. Very good. And what would my X be? What would my independent variable be here? The number of books that you bought and or sold, correct? I mean, that you sold and or made, right? Copies of books are the same thing, buddy. Book, copy of a book. You all have the same copy of a book, so it's how many books you sold. Thank you. Does that make sense? Okay. What's my revenue equation? How much do I make? Sir? Y, which is the revenue, equals $2 for every book that I sell. So if I sell 100 books, I make $200. Does that mean that I made $200 in profit? No. What is my expense equation? Sir? Fantastic, brother. Fantastic. Awesome. It costs 80 cents to bind, okay, and package each book. So that's 0.8x. Plus, it costs $864 for the initial cost. That's what it costs. When do I break even? How do I do that? What do I do? Very good. Yeah, you're going to substitute. Substitution. Y equals Y. So 2x equals 0.8x plus 864. How do I solve here, my brothers? No. Subtract 0.8x to both sides. You could have multiplied by 10, but I wouldn't have done it in this case because there was only one decimal. But if you wanted to multiply by 10, my brother, you could. This is going to be 1.2x equals 864 divided by 1.2. X would equal. Please note that when you're doing this, some of us are forgetting the basics. You got to move the decimal. Thank you, son. 1 to the right, so that means 1 to the right. Bring it up so you don't forget it, sirs. 82 go into 86 7 times. 12 goes into 86 7 times, which is 84. 2. So 720 books must be sold to break even. That's not great. That's a little high. If it's a really good book, I'm sure it'll be no problem. But that's a lot of books to sell just to break even. But good point. $2 for a book is extremely cheap. Way to think. Thank you, son. Does that make sense? What if I told you, what is my break-even revenue? Half. What does X equal here, guys? So what would my break-even revenue be? $1,440. Does that make sense?
Yes.
Okay, good. Yes, sir.
Plug in the 720, plug it into the equation.
Yes, but I had asked for my revenue, but since this is a break even, if you plug it into the expense or the revenue, doesn't it have to be 1,440? Because it's a break even. Does that make sense? All right. So that's break even, guys. That's one type of equation, that word problem you're going to have to master. I'm so sorry about those. No, that's not technical. That's just a bell. Okay. Now, guys, we're going to, yes, sir. On the test, I'll tell you, I'll say, find how many, whatever, widgets it is to break even. And maybe I'll just ask for that. Maybe I'll say, find how many widgets it takes to break even and find the revenue of the break even point. Then you would have to plug them in. Does that make sense, son? Thank you, sir. Please pay attention to this, guys. Please, please, please. This is the one type of equation that I can show you a different way to do it. I don't think you'll like it as much. So I'm going to do my best to show you how to do this using a system of equations. In my opinion, I think it's a lot easier to do it in a system. Let me show you. One thing before I do anything. Percent to decimal. Please remember, guys, that when we're going from percent to decimal, what's the last letter of decimal? L. So you go to the left 2 places. You move your decimal 2 places to the left. Percent to decimal, L, left. Percent to decimal, 2 places to the left with the decimal point. Now, knowing that, let's pay attention. A dairy farmer produces low-fat milk containing 1% fat and whole milk containing 3.5% fat. How many gallons of each type should be combined to make 100 gallons of milk that is 2% fat? First of all, what are the 2 variables I'm dealing with? Because here's not a break even, so it's not a revenue. Thank you. We're going to call X low fat, and we're going to call Y whole. Is everyone with me so far? I said so fat. Is everyone with me so fat? No. Does that make sense so far, guys? Okay, now, remember, on regular ones like this, there's a totals and there's a values. So, says how many gallons of each type should be combined to make 100 gallons. How would I do that? How many gallons of each type should be combined to make 100 gallons? How many gallons of each type must be made to make 100 gallons? How would I write that equation? The number of the gallons of low fat plus the gallons of whole milk have to equal 100 gallons. What's so hard about that, my friends? Guys, seriously. What do you mean you didn't understand what I was asking? How many gallons of each type? How many types did they give you? A low fat and a whole. Should be combined to make 100 gallons. What do you mean you were confused? We don't know anything about low fat and whole milk. All we know about low fat is that it's 1% fat and whole milk is 3% fat. How many gallons of each type make 100? How many gallons of low fat plus how many gallons of whole give you 100 gallons? Does that make sense? Now, values. 1% of the whole, of the low fat, right? 1% times the number of gallons of low fat, plus 0.035% of the whole milk must equal 0.02 of 100. Let me explain this because that is the one wrench that is thrown into this equation. The reason that I multiply this 0.02 by 100 is because don't I want to make 100 gallons of 2% milk? What does of mean? So 2% of 100. That's why I did that. Yes, sir. Why do I have to put 0.00? Didn't we just go over percent to decimal, son? 2%, son. 1, 2 to the left. I thought you guys all told me that you understood that. You even made fun of my la 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 L. And now you're asking me where did it come from. Please pay attention, boys. Please. And in this case, very good, son. I would use elimination. Okay, what do you want to get rid of? The x? Yeah, me too. I would get rid of the x as well. So how would I get rid of that x? Let's see who's really thinking here today. If you multiply by 0.01, you don't cancel anything. Now, if you multiply by negative 0.01, now you get it. So this is going to be as follows. So, okay. So now, let's go ahead and distribute. So we've got negative 0.01x minus 0.01y equals negative 1. 100 times 0.01 is 1. If you don't know how I did that, do it the long way, please. Plus 0.01x plus 0.035y equals 2. Again, the trick here, guys, is this part. Remember, the values is 1% times the gallons of 1% plus 3.5% times the gallons of 3.5 of whole milk must equal 2% of the 100 gallons. So you got to put of. You got to put that times. That's the only trick here. That's different than all the other ones we've ever done. This is the only time you're going to have to do that when you're dealing with percents, I promise. So now in this case, you cancel. This is 0.025. Please revisit your decimal skills. You got to line up the decimals and subtract correctly, please. For example, this is 0.035 minus 0.01, which is 0.025. Please revisit your decimal skills. And now you're going to divide by 0.025. Divide by 0.025. It's going to come out to 40, but I'll show you why. 1, 2, 3 to the right. 1, 2, 3 to the right. 25 goes into 104 times. 0, bring that down 0. So that's 40. So there's going to be 40 gallons of whole milk. How many gallons of low-fat milk would I need for this 2% solution of 100 gallons? You're going to plug it in. X plus Y, which is 40, equals 100. So X equals 60 gallons. So to get this 2% combo, 2% milk of 100 gallons, you're going to need 60 gallons of low-fat, 40 gallons of whole. Does that make sense, gentlemen? Really important. Yes, sir. Oh, okay, we're going back now, but the question was, we don't put the revenue and expenses as an ordered pair. Well, it depends. If I simply ask you for how many, for example, in this one, how many hats do I need to break even? It's just 200. They ask you for one thing, right? Now, if they ask you for how much revenue did you make at the break even and how many did you need to sell to break even, then it would be 200 hats, comma, $2,500. X, Y. Yes? Yes, sir. So, okay. So anyways, let's move on to number 4 now. Okay. Now in this particular case, In this particular case, 1 inch in coolant solution is 20% alcohol. Another inch in coolant solution is 12% alcohol. How many liters of each solution should be combined to make 15 liters of engine coolant solution that is 18% alcohol? None of you have this down in your PDFs, so I don't know why I don't see you writing them down. You must write this down because this is not in your PDF. I just added this. Okay, I just added this. In fact, I'll give you literally 1 minute to copy it before I continue. Okay, guys, hopefully you wrote that down by now. Let's go over it. 1 inch in coolant solution, basically that's antifreeze, okay? 1 inch in coolant solution is 20% alcohol. Another inch in coolant solution is 12% alcohol. How many liters of each solution should be combined to make 15 liters of engine coolant solution that is 18% alcohol? First things first. What are my variables, y'all? Okay, X is the 20% alcohol solution. I'll just put solution to make life easy. The 20% solution, and Y is the 12% solution. Okay, so far we're so good. Let's look at our totals, please. How many liters of each solution must be combined to make 15 liters? Very good. The 20% solution plus the number of gallons or liters of 12% solution has to equal 15 liters. My values. A certain number of liters of 0.2, right? 20%. So a certain number of liters of 20% plus a certain number of liters of 12%, which is 0.12, has to equal 15 times the 18. Because it's an 18% solution of 15 liters. Does that make sense, boys? You promised me. That's the big key here. That's what kills everyone on the quizzes and tests. They forget that last part. It's 15 of 18%. So you got to multiply those two. Does that make sense, guys? Come again, my brother? What? I'm sorry, what are you saying? The answer, there is no... Oh, okay, you mean the product of 0.18 times 15. Okay, you were telling me the answer, son, and I don't know what that meant because we haven't solved it yet. Sorry. I understand what you meant, but what you meant and what you said were two different things. I am sorry. So, yes, this is going to be 2.7. Thank you, sir. Okay, great. Now, what do? Sir? He wants to get rid of the x, so he's going to multiply negative 0.2 to both sides. So I'm going to get negative 0.2x minus 0.2y equals negative 3.0. Because 15 times 2 is 30, move a decimal, 3. And then I have plus 0.2x plus 0.12y equals 2.7. Please be careful here, my friends. The setup, as you can see, isn't that hard. The math is not that hard, but there are decimals being involved here. So I beg of you, please be careful. This cancels. Negative 0.2 plus 1.2, it's going to be 0.2 minus 0.12. Got to line the decimals. Well, that's 0, so it's going to be negative 0.08 because remember, negative 0.2, there's more negatives than positives. So it's going to be negative 0.08 y equals negative 0.3. Does that make sense so far to everybody? Now, let's go ahead and make our next calculation. Divide by negative 0.08, divide by negative 0.08, 0.08 on the outside, 0.3 on the inside, 1, 2 to the right, 1, 2 to the right. Okay. And that's a 0. 8 goes into 30 3 times, which is 24. Then that's going to be a 6. That's going to be 7, which is 56. And then that's going to be a 5. Very good. So y will equal 3.75 liters. How do I find how many liters of X of the 20% solution? Very good. X plus 3.75 is equal to 15. Subtract 3.75 to both sides. Please remember to line up the decimals, please. So X is going to equal, that's going to be, it's a 5, 9, 2, 4, yep, 11.25 liters. So in the end, my solution is 11.25 liters of the 20% solution plus 3.75 liters of the 12% solution will give me a 15-liter, 18% solution of engine coolant. Yes, sir. Do we ever round up? Absolutely not. And I'm not trying to be funny or a jokester. If I were to round up, son.
I think I can fit through another equation.
But no. What's going to happen? If I round up, I'm taking away the exactness of this. If I round to 11 and I round to 4, I will not have an 18% solution. I'm going to have a different percent solution. This is exact. Math is exact. It's like, and again, I'm not trying to be funny, but when an engineer is building a bridge and he tells the construction crew, I need the lanes to be, I'm just making up a number, 17.75 feet long. They can't just make it 18 feet because there's a calculated amount of material that they paid for, first of all. Secondly, maybe there's not enough space for that extra 0.25 of a foot. So it's always going to be exact, unless I tell you, use approximate answers. Thank you, son. All right, my brothers. Good lesson.